Hello, my name is Matthew Watkins. I'm a performance engineer with our technical support team at ServiceNow, and I'm going to be talking about how to troubleshoot performance using client interactions and transaction logs. So the transactions all users module is how you can get to the transaction log table, and client interactions are something new for Next Experience. And client interactions are a way of showing all of the transactions related to a single user experience, a user interaction. And why is that important? So let's talk about the history of ServiceNow's UI. We've moved from a multi-page app to a single-page app architecture, like the whole rest of the industry. And that means more responsiveness, and it means more transactions for each interaction. So historically, with the when we had Jelly and Prototype as our core UI, which is still in many parts of the platform, you had a single interaction with the UI that would go up to the server. The entire web page would be rendered, sent down, and there'd be a re-render, and you could measure just that one transaction to understand the user's experience. But with the single page architecture, as you can imagine, one interaction has multiple transactions. You can't just measure any one of those transactions to understand the user's experience. So we introduced the idea of client interactions. So for Next Experience, we have client interactions available, and they group together all those transactions. Our other UIs like Service Portal, Visual Task Board, Responsive Dashboards, those ones do not have client interaction enabled in them. It is just for Next Experience. Here's what our three tech stacks kind of look like side by side, some of the tables that are involved in defining those tech stacks and the technologies that underlie them. Next Experience navigation. These are some of the core tables that you can understand of how an experience gets wired together. So the main pieces of it here, the UX application defines the path, and each in the URL you'll see the path of whichever workspace you're in. UX app configuration is kind of the main configurable item, and everything else points to it. So you have screens and app routes all connected to your app configuration. A screen is an area of content, kind of a content pane within your experience, and an app route is how you get to your UX screen. Inside your screen, you have one parent macroponent with a bunch of little macroponents nested inside of each other. And those are how you have your components, the different components on the page. So when you look at the app route, it has some key fields here. The route defines in the URL right after the path. SOW form modal in this case is the route. And then you have mandatory parameters in the fields and optional parameters that follow in the URL after the keyword params. And so those are in key value pairs, and they can be in any order. So when you look at a client interaction, which remember is a recording of kind of an end-to-end recording of all the transactions related to an interaction, you can see what screen route was taken. You can see the screen fields that were provided at runtime, as well as the optional parameters. So you can understand, it gives you an understanding of what the user was doing at the time, what arguments were being passed in, and so forth. And you have a list of all the transactions, all the important transactions related to that interaction. So a little about how we measure the performance of an individual transaction. As you can see, there's a lot of parts of the transaction lifecycle. Basically, it goes from the browser up to the server, back down to the browser. And there's a couple events that we key into, and these come from a open source library called Performance Resource Timing, and it emits certain events during the lifecycle of a transaction, supported by all the major browsers. And we define duration as the time between fetch start and response start. Response start is basically when the first byte comes back to the browser. So the very first byte reaches back to the browser, we stop the timer. We also measure on the server side the total response time, which is both the wait time, because not every transaction gets to run immediately. Sometimes they have to wait for a thread, and then transaction processing time, which is the actual time spent on the thread. So that's doing all of the database queries and all the business logic. All of that processing goes into transaction processing time. And in pink here, I have the total UI time metric, and that starts when we kick off a mark, and it finishes when the seismic event queue and the network queue has stopped loading. And so that's how we measure the kind of end-to-end total time for the components. So having a look at how a single interaction is connected to multiple transactions, inside ServiceNow we store two important tables, the syslog transaction table and the sysclient interaction table. And as I mentioned, each interaction can have multiple transactions. They're tied together with this interaction ID field. We have a total UI time, which is measured starting with that mark and ending when seismic event queue and network queue has quieted down. We also have total UI time before load, and the load event we're talking about here is when the app shell macroponent, which app shell is the name for that, when you're looking at the UI, you have a header bar with menu items. That's the app shell. So inside the app shell, everything else happens. It's like the application, it's the shell of the application, and everything else happens inside that shell. So once the app shell triggers a load event, that's what we're talking about. So time before load is basically server time for the very first transaction in your interaction. And as I mentioned, then there's multiple transactions, those fire and fire and fire and fire. And once they've all fired and the network queues have calmed down, then UI time after load is marked, and those the end of that total UI time. We also have something called first component interactable time, or FCI time, and that begins at the mark as well, but it finishes after that very first component says, you can interact with me. You can scroll, you can click. And sometimes that is actually a more accurate measure of what the user is experiencing as far as interaction time. So they click on something. What they usually care about is, after I click, when can I start interacting with the page again? I don't care if every single thing on the page is loaded, but once I can start interacting again, that's when they consider, that the page is loaded. So FCI time can help understand that. All right, so now I'm going to briefly show you this and talk about some of the important fields in the interaction and the transaction table. So here I am. If I go to a workspace, and I look for interactions within the last minute, note that these interactions take a while to record. So they're waiting on the client side for all of everything to die down, like I mentioned. So see, it came down, took a while, even after the page had totally rendered, for that client interaction to get recorded. And the created time that's displayed here is when the interaction gets recorded, not when the interaction began. But if you want to figure out when the interaction began, you can look at the client timestamp. We're going to make this human readable in the future, but for now, you can go to something like Epoch Converter and find out here in my local time, 10:50:11. So you can see 10:50:33. So 22 seconds later is when the interaction actually got recorded. Interaction ID, I mentioned, is the way that we link together transactions to interactions. So if I looked for all the transactions with that interaction ID, I would find all the ones related to this interaction. Type is going to be page load, navigation, or in-page interaction. But mostly everything is going to be a navigation. So navigation means you're inside a page and you click on something and move around. Page load means, like I did, I loaded a whole new workspace. So there's one page load, and then you generally have navigations within that page. You can see the application, it's the compliance, workspace. The referrer will give you the entire URL of either the page that was loaded or the page that you were on when you did the interaction. Screen route, remember, points you to the screen that was loaded. And we have total UI time and first component interactable time. In this case, they're the same, about 16 seconds. The session number, which is handy if you're looking at our node logs, which are the more granular log stored on the server. It could show you errors and certain slow queries and things like that. And we have interruption, which could be page visibility change, or a click, or a mouse over, or a key press. It's anything, or even a timeout. It's anything that interrupted the recording of total UI time. So page visibility change means that we navigated from one tab to another. So remember, I navigated away from the home page to the client interactions before it had finished recording that total UI time. So if there's an interruption, it throws a little bit of doubt onto what total UI time means. So if you wanted to purely understand your total UI times, you might say only look at total UI times where there's no where interaction type is none. So let's take a look inside this client interaction record and see some of the interesting fields. There is total transaction processing time, and this is actually adding up from the transactions related to the interaction, taking all these transaction processing times and adding them up together, which can be a bit deceiving because those transactions could be executing synchronously, and the total is just the sum. So it just takes all those processing times, adds them up together, and you could have simultaneous transactions processing at the same time. So it may not reflect really what the end user is experiencing. Total session wait time, same deal, takes all the wait times, adds them up together. Refer, we talked about. Client cache hit rate, not going to talk about that one. Network latency. This is round trip time of a ping to fetch a static asset. So it's not related to this interaction per se. It is it's a separate ping that the client side initiates so that we can measure just the kind of the latency of the network itself. So the static assets that's being requested is negligible size. It's cached on the server. So there's virtually no server processing time. And so we're measuring the network time plus the server, but the server is so small as to be that it can be discounted. So whatever is measured here is really how long it takes for a very small package to go up and down across your network. So it can help to understand, you can look at this by region and understand for different regions what is their network latency and compare, users in one region are all complaining, maybe it's the network. Variant ID is the sysID of a screen variant, so you can have the same screen appear different ways for different personas. Content download size and download time are what they sound like. All our times, by the way, are measured in milliseconds, so 3.3 seconds of download time. Client transaction, linked transaction client metrics. These are all of the durations. And remember, we talked about duration. It's being measured from the fetch time until the response start. Duration is the total, what the client perceives, the client side, what it perceives as the transaction, total transaction duration. So we measure for each of the related transactions, and we store their first 12 characters of their sysID. So if I go down into the related transactions, and I build a filter for sysID, starts with, I'll find the transaction from that list. It was this one. 173 was the duration. And 173 minus 30 is 143. So that's how we get client network time. So it's a derived value, and we can assume that if the full duration, remember, is from fetch start until response start, and we know response time is the end-to-end server time, both the wait and transaction processing time, we can subtract that from the total duration, and whatever's left must be network time, which is, it's a very accurate, it's a heuristic, but it's very accurate and reliable. So here's an individual transaction, and you may see, if you see really high client network time, maybe something in the firewall was frozen up, or something inside of one of your routers is having issues, or any of the components along the network path might be responsible for that. And of course, if you see really high, unusually high download size, maybe that's a factor there. It's not the network itself, but it's a huge payload coming down across that network, will be slower than a small payload. Sometimes you'll see really high total UI times, unreasonably high, and that can be due to a component on the page that is very active with the network. It's sending up requests over and over, and that may keep that network queue from dying down. Remember, total UI time is considered done when the network queue is idle. So there could be a certain component on there that technically the page is loaded, you can interact with it, but if there's a certain component that's very busy and it keeps pulling down data, that could blow that UI time out, make it look really artificially large. We have a timeout at 30 seconds. So if you see an interruption type of timeout, that means that there was something busy on the page, and it may or may not actually reflect user experience. So total UI time, take it with a grain of salt. Compare it against the first component interactable time, compare it against the actual transactions that are connected. And one more thing, the idle transactions for interaction, these are transactions that are repetitive, and they're outside of the flow of actually rendering the screen, rendering the interaction. So UI presence is an ongoing transaction every 30 seconds to check to see is anybody else looking at the same record that I'm looking at the same screen that I'm looking at. If I reload this now, you'll see a whole bunch more of these. And they work on a long pull technology, but every 30 seconds. And they're just checking to see is anybody else looking at the same record that I am. So we consider those idle. We take them out of you don't have to consider them when you're trying to figure out, who is responsible for my page being slow. But in this list, the first place I would look to see is response time. So I'd order them by response time. Z to A. And then you would check transaction processing time to see were they actually busy doing something or were they waiting for something else. So you see this one has nearly a second of response time, but only 58 milliseconds of actual processing time. So he's more of a symptom than a cause. And in this case, it looks like, the longest running transaction processing time was only 2 seconds out of that full 16-second component interactable time. So it's very possible that most of the time here, that 16 seconds of total UI time was really client-side activity. We could also look for if any of these has really slow network time. Right? Client network time. Okay, is there. Not too bad. But there was, depending on if these were running simultaneously. Okay, their processing start always at the same time. Yeah, so it looks like the client was a little congested here. We can also look at total wait time. Not too high during that period. Remember, wait time will be discounted from client network time because client network time is duration minus response time, and response time includes total wait time. But yeah, if you found one of these that was the slowest, then you would go look into it, and you could look at the URL and try and understand what that was doing. I'm not going to get into that part of the investigation at this time, but you would look at your more detailed node logs and try and understand, was there a slow query? What was making that particular transaction slow?